In this video, we will show how to design and build a decentralized app on example. As an example, we will finish coding the game. I call it that game as element words. Idea of the gameplay is very easy. There are 4 elements: water, fire, wind, and ground. The water extinguishes the fire melts the ground stops the wind, and wind freezes the water. You create a word in some elements type, and then you fight with other players, pulling out any word from your dictionary. For the choice of the word is given 20 seconds. You win when the element of your word surpasses the element of the word of your opponent, and you lose if the element of the opponent's word overcomes yours. If the elements of the words are the same, then the one with the greater value of the word will win. The value of the word increases as the word wins over the others in battles. Since creating the game from the scratch will be too long and tedious for our tutorial, we will code the semi-finished game. Download the repository from the page from the given address. Open it in Unity3d. This semi-finished game has all the working transitions between scenes and panels, but gameplay part is not yet implemented. Click on the pause in this video and try to play with the project. Did you understand what buttons are working and which ones are not? Excellent. We will implement the last one. Let's start with the first scene, then go further. First, we are importing the NeoLux into the Unity, the library to work with the Neo blockchains. Then we run the NeoLocal to create the private net on the local machine. Actually, in our repository, the NeoLux was already imported, so we will skip that part. Let's start from the menu scene. It has 2 buttons that do not work: Import Wallet and Create Wallet. Wallet is a container of the address by which all other users, as well as machines on the blockchain net, can identify you. Since wallet is actually used in all game, better to define it on the global script. Define the public property called keys on the data script. Let's work with the script for menu scene. Type the following properties at the top of the script. These are links to the scene objects which are involved in the work of those 2 buttons. Attach the object from the profile to newly appeared options on Inspector for menu scripts. Type the following method after defined properties. Since we can't actually allow user to play the game without the wallet, we will disable and enable it based on wallet availability. After start method, type the create wallet. As you see, we generate the random sequences of bytes as a new address. We clear all the stored data from previous authorizations, and finally showing the main address. Back to the scene and add the listener to the Create Wallet button and choose a newly created method. If you test it, you may see generated address on the main panel. The last part of the code for this scene is making available the import. After the create wallet, type the following piece of code. We are trying to pass and generate the wallet information. If it's not working, we show the error. Finally, going back to the main panel. We can test with a new private net wallet. Now we should see the same address as we see in GUI. Little bit off topic. There should be some gas on the wallet to invoke the smart contracts, so we can't really use the newly created wallets to play the game. You may use the different options to solve it. Maybe send little amount of gas from the admin's wallet, or you may multi-site the smart contract invoke transactions. But for simplicity in our tutorial, we will use the importing wallet method to play the game. Let's look at the profile scene. Here's only one button which is not working. It's a word creation. Open the script for the profile scene. At the bottom of the script, add the create item method. Items should have the name. We set some random initial value between 1 and 5, making the key, which is a unique and full name for words. It's combination of element and your typed name, and finally we store it on local. At the profile, set the method to the create buttons listener. In the last scene, we have the one button which is not working. It's the Start Battle button. Add the following Start Battle methods. Here, if player didn't select some word from dictionary as candidate, we show the error message. Then we stop the timer. We are creating the random opponent words, show them on the battles panel, and after that we show the battle panel itself. Finally, we start the calculation of battle. After the start battle method, create the create random item method and calculation method too. In calculation battle, we show the basic welcome message with ugly animation. Then calculate the battle results and show to person the battle results. Of course, we do it with animation. And finally, reward the player for losing or winning the battle. The final source code's address is shown on the script. Go and copy the required methods into your script. Finally, we set the start battle method on the start buttons listener as well as on timer too. If player will select the item but didn't click on the start, we will do it for him. We now have a local ready to play game. Stop this video and play with it. And after that, we are going to code the blockchain part of the game. Before making the blockchain connector in the game, we need to make a receiver of the requests from our game at the blockchain. We need to write the smart contracts. Let's create the smart contract. Create the new NeoContract project. Replace main method with the main method as you see on screen. We have three operations on contracts: put, delete and update the words on the blockchain. Now we need to test it. If everything works, we can deploy it to the private net. Open the Unity3d client, open the wallet with a minimum 500 gas amount. During the deployment, we save the address of smart contracts. Later, we will use it in the Unity to find the smart contract on blockchain and invoke it. To test the result of our deployment, go and invoke it through GUI client. Now let's make the blockchain at the gamepad. Since the blockchain connection occurs on the both profile scene and the battle scene, we'll make a global script that will be available throughout the game. Get the Neo script from the address as you see on screen, add it to the Unity. And make it global. And to make it global, we attach it to the data prefab. Set the required data at the script. Also set the address of smart contract. As you see in the beginning, we initialize the RPC client for private net. Here is your challenge. Try to understand the connection and wait for transaction methods. Pause this video and look at that code. Now we need to invoke the smart contracts at the required places. We do it in three situations: when we create, update or delete the words. Go to the data script. At the start of the script, call the NeoScript2, and inside of the create, update, delete methods, invoke the Neo methods with the required parameters. Save the game and play it. Actually, our game is far from being perfect. There is lack of security, there is not enough of connection between the player and the blockchain. The player doesn't see the connection in a convenient format. So far he can learn through the console, failure or termination or the finishing of the transactions on the blockchains. For the solution, you could use a wait for transaction method in Neo. Try to figure out how to do it. We do not use the potential of blockchains to make the game really fun. Since the words are in the chains, all of them are open to anyone. We could use this before the battle to show all words of opponent to you, including their stories of battles and the value of words. Still, very much is not done, and probably you will extend the game to the full one. If you do it, then ask the test guys for testing before publication. That's all. I hope to see your game in the future.